Hi everyone. So finally we reached question number 50. That's all about how to find torque and angular momentum. So it's all about torque and angular momentum. Now the very first thing is we need to understand what is moment of torque. Sorry, moment of force. Moment of force nothing but torque. But in the physics whenever the word moment comes, it is nothing but you are multiplying in terms of distance. So similar way, the torque is also defined as R bar cross F bar. Nothing but the magnitude is RF sine theta. So moment of force is defined as torque. So as it is given according to the equation, it is the cross product of position and force. So position of the particle on which force is applying with respect to the reference and the force and the angle between them, all the three things it matters. Now similar way we can also define angular momentum, that is movement of linear momentum. Moment of linear momentum, that is L bar equal to R bar cross B bar, so that the magnitude is Rp sin theta or L equal to mvr sin theta, because linear momentum equal to mass into velocity. So this is what the definition of torque and angular momentum. Now when you want to find the angular momentum or torque about a given reference point or axis. So first when you consider the particle, see, you have to find the force direction in which it is acting. Then you take the position of the particle, then this is the angle will become, this is R bar. So R bar cross F bar. Or else what you can do is the torque tau equal to R perpendicular into F simply. R perpendicular how to draw is you draw a line along the force direction, along the line of action of force. Then draw the perpendicular from the reference point on the line of action of force. Then that will become R perpendicular, nothing but R sin theta. Then the torque tau will become R perpendicular into force. Similarly, when you consider a particle of mass m moving with a velocity v, then first you find the direction of position vector. Then you draw a line along the velocity, then draw the perpendicular from the reference, that is called R perpendicular. Then the angular momentum will become R perpendicular into P. So both of them we can find in similar manner like R perpendicular into F or R perpendicular into P. So you have to draw a line along the line of action of force, or you have to draw a line along the direction of velocity, direction of motion, and draw the perpendicular from the point of reference. Then you will get the torque and angular momentum. Now, one more thing is sometimes they will also ask questions like, what is the torque and angular momentum of a rigid body rotating about fixed axis? When a rigid body, for a rigid body rotating about any one fixed axis, rotating about fixed axis, the equations are given by angular momentum is I omega, torque tau is dl by dt, that is I into alpha, where I is moment of inertia. Also, in case alpha is constant, you can also apply equation of motion like final angular velocity is omega equal to omega naught plus alpha t, and the angle rotated within a time t is omega naught t plus half alpha t square, and omega square minus omega naught square equal to 2 alpha theta. So the question can be asked sometimes based on this also. So just try to remember each and every formula, then we can solve the questions. Now let's see few questions. The very first thing is find the torque of a force. So they have given force, that is I cap plus 2j cap minus 3k cap. And the position vector also they have given directly 2i plus 3j minus k cap. Then they are asking torque. So the torque tau equal to r bar cross f bar. That means you have to go for determinant, that is I minus j k. So alternative plus minus we will take. Then coefficient of r bar 2, 3 minus 1. Then 1, 2 minus 3. Then if you expand, I coefficient means you have to remove the row and column linked with I. So that 3 into minus 3 minus 9 minus half minus 2. So plus 2 it will become. Then minus j, then 2 into minus 3 minus 6 plus 1 plus k cap 4 minus 3. So that it will become minus 7i cap minus half minus plus 5j cap plus k cap. So this is the torque. If they ask magnitude, then you find the magnitude of the torque vector by taking under root of I coefficient square plus j coefficient square plus k coefficient square. Now let's take the another question. A small boy of mass 1 kg is attached to one end of a small ball of mass 1 kg is attached to one end of a 1 meter long massless string and the other end of the string is hung from a point. When the resulting pendulum is 30 degrees from the vertical, what is the magnitude of torque about the point of suspension? See, first it is suspended from a fixed support, then it made like this. So it is making some angle 30 degrees with vertical. So that here mg one force will act, another one is tension. Now about the point of suspension they are asking. But about the point of suspension when you take, the tension is passing through that point. Means the line of action of tension is along that. So the torque due to tension is 0. Then only we have the torque due to mg. Now what I said, you have to draw a line along the line of action of force. Then you draw the perpendicular, that will become r perpendicular. Then torque due to mg will become r perpendicular into mg, where this is L. Now this is theta means this is theta. Then what equation I can take is sine 30. Sine 30 means r perpendicular by L. Then r perpendicular will become L sine 30, nothing but L by 2. So L value 1 meter, M value 1 meter, 1 kg and G value 10. If you substitute, you will get the answer. So this is how you have to understand what is the line of action of force, and you have to consider what is the reference point given and what is the perpendicular distance of reference point from the line of action of force. Then you can find the torque. Next question. A car of mass 300 kg is traveling on a circular track of radius 100 meter with a constant speed of 60 meter per second. Calculate the angular momentum. Now, for any body moving in a circular path with a mass m of radius r, the velocity at every point is along tangent, which is perpendicular to position r. So that the angular momentum will become mvr sin theta, and here theta is 90 degrees. So the angular momentum will become mvr. So mv is 300 kg, v is 60, r is 100. So that 18 into 10 power 6. So kg meter square per second. This is the angular momentum formula for every particle moving in circular path with constant speed, mvr, about the center of the circular track. Now a particle of mass m is projected with velocity v at an angle theta with the horizontal. Find its angular momentum about the point of projection when it is at highest point. So here they are talking about projectile motion, and in projectile motion at highest point means suppose initial velocity is v, then at highest point only horizontal component will be there, that is v cos theta. Now this is the reference point. Now this is the direction of motion at that point. Now this is the r perpendicular, as I said, nothing but that is the maximum height. Now what is the maximum height formula? That is v sin theta whole square divided by 2g. That means r perpendicular is nothing but h maximum in this case. Then what is the angular momentum formula? I said r perpendicular into p, nothing but h maximum into m into v. V is how much at that point? V cos theta. So you substitute h maximum value, then you will get the answer. That is h maximum is v square sin square theta by 2g times m into v cos theta equal to m v cube sin square theta cos theta by 2g. So this is the angular momentum of the projected body at its highest point. If they ask about at any random point, means at any instant, then you have to find its position r bar, xi cap plus y cap, x displacement and y displacement. And you have to find velocity vxi cap plus vy j cap, x velocity and y velocity. Then you have to go for r bar cross v bar. That will give you the angular momentum, because angular momentum is m into magnitude of r bar cross v bar. So that also they can ask. So just try on your own by taking r bar and v bar. Now one last and final question. Here a 40 kg flywheel in the form of a uniform circular disc of 1 meter radius is making 120 rotations per minute. Determine the angular momentum. So angular momentum means, as I said, it is I into omega. So what is the moment of inertia of the disc? So the disc moment of inertia is mr square by 2, where m they have given as 40 kg and the radius is 1 meter. So you can find moment of inertia. Now omega equal to 2 pi by t or 2 pi f. Now omega equal to 2 pi into f is frequency, 120 rotations per minute, but we want per second, so by 60. So that you will get omega value also, that is 4 pi. So now we got omega value and you can find moment of inertia. Then we can find the angular momentum using the formula I omega. So that way, sometimes they can ask the angular momentum or torque on of rigid body also. Of course, in the next lecture, we will also study the rotation of a rigid body about a fixed support and the quantities associated with the rigid body. But here, as we are discussing torque and angular momentum, so as I said, they can also ask the question based on torque, where torque tau equal to I into alpha. Again, I is moment of inertia and alpha is angular acceleration. So as I said previously, in every question, most of the times, rotational motion or rolling motion or torque or angular momentum, we have to use the moment of inertia concept always, because you should know how to find moment of inertia of any rigid body, I mean regular rigid body like ring, disc, sphere, cylinder about any given axis. By using parallel and perpendicular axis theorem, then only you can solve the questions based on rotational motion. And similar questions I have given as assignment. So please try to solve all the questions. So thank you all of you. We'll continue in the next session with the next class. Next question. Thank you.